welcome to a little review about the Unit 4 Quiz 1. Alright, so for number 1, what I'd like to do is to write our linear function in slope-intercept form. Let's get started. Now the first thing I'm going to do is write f of x equals, and then I'm going to have some fraction with an x, and then we'll have our y-intercept. Now I see the y-intercept already, it's negative 5, so I'm going to write a minus 5. Now what I'd like to do is count how much do I go up and to the right from that y-intercept. And that's going to be our slope. All right, 1, 2, 3, up 3, to the right 1. That's our function. Next one, f of x equals some slope with an x. All right, my y-intercept is right here. It's a positive 5 this time. Now let's count. How many do I go down and to the right to get to my next point? We're always going to the right. Now if you're not sure if you're going up or down, try going up and to the right, and you'll see that we don't actually hit the line. So you try going down and to the right instead. 1, 2, down 2 means negative 2. To the right, 1, 2, 3. Negative 2 over 3. Let's look at this one. I'm going to start off again. F of x equals some slope and x. My y-intercept is right here, so that's positive 3. For my slope, it looks like I'm going up. So I go up 1, 2, to the right, 1, 2, over 1. Let's try this one out. F of x equals some slope. Right here, it looks like that's positive 3, so plus 3. And then it looks like I'm going down 1, 2, negative 2, to the right, 1. I'll make this just a little smaller. Perfect. So that's how we look at graphs and then write slope-intercept form from them. Number 2, use the tables below to answer the following questions. All right. Letter A, determine the average rate of change, the slope. Let's do it. Now the average rate of change, the way we look at this is the change in our y's, because that's our rise, over our x's. So the formula states that I eventually gave you that we do our second y minus our first y, y2 minus y1, over our second x minus our first x. So exactly how we did our common difference. Second term minus first term. All right, so for letter A, we got 9 minus 6 over 3 minus 2. So that's 3 over 1. Okay. Next, write a function to model the table of values. All right. Well, we got f of x equals, we know our slope is 3 over 1, because we got it from here. Actually, let's do highlighters. Now the y-intercept. Now, it's kind of hard to see here because they don't have a 0 on my table. However, my x's are going by 1. So that means I can go backwards 2 spots. So 1 and 0. So we're subtracting 1 this way, subtracting 3. So then 6 minus 3 is 3. Oh, 0. Plus 0. Letter C asks us, determine the value of the function after a constant rate of 8. So what that means is we plug 8 into our x's. All right. 3 times 8 is 24, plus 0 is 24. Beautiful. Again, it was a little tough to see those that y-intercept, but I did just go backwards on my table. I don't think on the quiz I plan on giving you anything without a 0 in it. So let's just keep that in mind. All right, let's take a look at this one. Letter A, determine the average rate of change. Let's do that. We're going to do second y minus first y for the top. And second x minus first x for the bottom. So we're finding the pattern. Now, some of you might be able to look at this and see the pattern immediately. Good for you. So -2 minus -4. All right. 15 minus 19 is -4. 2 minus -4 is +2. -4 divided by 2 is -2. We have our m. So function form, f of x equals -2x. Now let's look at our table and see, do we have x equals 0? So a y-intercept on the table. Looks like we do. Plus 11. Determine the value of the function after a constant rate of 5 means we're plugging a 5 in instead of our x's. -2 times, I don't know why I wrote a -5, times 5 is 10. 10 plus 11, sorry, -10 plus 11 is 1. That should definitely be in your calculator. -2 times 5 is -10 plus 11. Yeah, okay, good. I don't know why I was doubting myself. Okay. Expect to see something similar to this on your quiz, where you look at the table and see the y-intercept. Let's take a look at the next one. Determine the average rate of change for this problem. Okay, let's do it again. Second y minus first y over second x minus first x. All right, for our y's, -3 minus -8 gives us a +5. For our x's, 3 minus 0, 3. We got our slope. Fantastic. So f of x equals 5 over 3x. For our y-intercept, let's check the table and see, do we have any numbers, any points where x is 0? We sure do. Here it is. Our y-intercept is -8. Determine the value of the function after a constant rate of 15. That means we're taking 15 and we're plugging it into our function. I highly suggest doing this in your calculator. However, 5/3 times 15 is 25. 25 minus 8 is 17. I am a calculator. Let's take a look at this table. Once again, let's find the average rate of change by finding the pattern of the y's over the pattern of the x's. For our y's, 3 minus 10 gives us -7. For our x's, -1 minus -2 is +1, so our slope is just -7. And yes, of course, you can leave it as a fraction. For our function notation, f of x equals -7x, because that's our slope. For the y-intercept, take a look at your table. Do you see where x is 0? Good. -4. Letter C. Determine the value of the function after a constant rate of 6. That means we plug 6 into our function. Again, this part should definitely be done in your calculator, but since I'm your calculator, -7 times 6 is -42, minus 4 is -46. So very similar situation for 3 out of the 4. The only thing that required a little extra work was this first one, where we did have to kind of go backwards and find what the y-intercept was. Number 3. A cactus is currently 4 inches tall and grows 3 inches per year. Let's write function notation. The first thing that I want to write down is my slope. So what is changing? What's the average rate of change? Well, in this case, the cactus is growing 3 inches per year. So that's the average rate of change. The cactus starts at 4. That's your y-intercept. How tall will the tree Sorry about that. That should definitely be cactus. How tall will the cactus be in 12 years? We're going to plug 12 in. Three times 12 is 36. 36 plus 4 is 40 inches. That is a large cactus. Number 4 and 5. Boy, I have some typos here, huh? This should be 4 and 5. Well, that's too bad because I already printed this. Oh well. Anyways, let's graph. So for each of the following, a function has been given along with its graph. All you have to do is do the transformation. So number 4 already has 2x plus 1 graphed. -1 times f of x means take our coordinates and multiply the y's by -1. Now I have 3 points there for you. I don't care which you use. I'm going to personally go with this point, 0, 1. And I'm also going to use this point, 1, 3. Okay, so what I'm going to do is multiply just the y's by -1. So this new point becomes 0, -1. This new point becomes 1, -3. Let's graph them. 0, -1 is down here. 1, -3 is right there. And there's my line. I decided not to use this point there because I don't know what it is. It looks like it's a half, but I don't want to guess. Number 5. Here's the graph of x plus 5. And what it's asking us to do is f of x minus 3, which really means y minus 3. Now there's 2 ways of doing this. One way is taking each of these points and moving them down 3 spaces, which is not too bad. Or you can also write down the original coordinates, 0, 5, and -5, 0, and then subtract 3 from the y's, which gives us these 2 new points. 0 stays, 5 minus 3 is 2. -5 stays, 0 minus 3 is -3. So 0, 2, -5, -3. Still ended up in the same spot. So when we're moving up and down, we don't necessarily need to write down the original points. It's a good habit, but you don't need to. Now, when we're multiplying, you definitely need to write down the new points. Maybe I can help color code that that's what this became. That's what this became. Okay. If you have any questions, I decided I did not like that, please don't hesitate to ask me or whoever your teacher is. And have a wonderful, wonderful rest of whatever day it is for you. Bye!